0.3402. Well, you need to convert that to at least 4 significant digits. It tells you that in number 2, I think, on page 25. And so when we do it that way, the change in velocity y equals 5.779 times 10 to the 4th meters per second. Well, why 9? Well, you need to round that up, right? 5 or more, round up. Okay. Alright, so now let's move on to our next step. So now that you have the table row 1 filled out, your next step is going to be to go to table 1 row 2. So you can look at page 26 number 4. And what we're doing here, calculate the next x position. So now we want to know where the next x position was of this alpha particle, okay? And to determine that, that's for row 2 in column 1. Alright, so here we go. So we need the new x. And to get the new x, we take the old x and we add it to the Vx multiplied by the change in t. Okay, so if you look back on page 25, number 1, it says that the alpha particles advances along its path at 1.33 times 10 to the negative 20 second intervals. Remember that? Okay, so therefore, change in t, that's change in time, that's the change in time, 1.33 times 10 to the negative 20th per second. Or not per second, excuse me, but you see that right there. Okay. So Vx, so velocity of x, equals the initial value from row number 1, column number 1. So I'm talking about this Vx right here. You take it from row number 1, column number 4, table 1, and this is what it is. Velocity of x is 1.500 times 10 to the 7th. Then you take your x old, which was from, table 1, what was that? Row 1, column 1? Okay, so put into your calculator as follows. Same thing, you got this big parentheses. Remember, there's going to start there and it's going to end here. Then you go, okay, so here we go. Let's see if we can get this whole thing in here. So, for x new, we take the x old. There's the x old. Parentheses. Put the x old in, another parentheses, close it out. Plus, here's our plus, Vx times change in t. So make sure you parentheses the Vx, make sure you parentheses your power, and then parentheses there, new parentheses, okay, and then keep going, parentheses, parentheses. Here's where you got to close out this parentheses here, then you got the parentheses out here, it closes in the whole thing. And your new x new equals negative 4.005 times 10 to the negative 13th meters. So that's for row 2. Row 2 x velocity. Okay, next, do the same for the y. So the y, it's the exact same thing that you just did. So except you take the y new, you take the y old plus the vy plus the change in t. So the only thing that's going to change this number, and this number is going to change. This number is going to be the same, and it's going to. So this right here will be the same. So then plug that into that same formula. So for R new, go back to step number 2. So when you want to get the new R value, which is going to be row 2, column 3, your distance between the particles R, remember to go back to what we talked about right over here, right? This one right here. Okay, go back to that. Okay. Then we need to switch on to. We need to calculate the new y velocity. Oh, there we go. I just told you. Sorry, forgot I wrote this down. So the new y velocity, you just plug that in from 5th row, number 1. Put it into your calculator as follows. So here it is right here. Make sure you got your outer parentheses. In this case, you only have a 0. You're going to have 0, so it's going to look strange. You don't have a whole bunch of parentheses. So you're just going to take your change in velocity y. Oh, I'm sorry. We're talking about something different here. So this is the new vy. Okay. Let me back up a minute. I apologize if I miscommunicated. So we got our x new, our x velocity, or x new equals okay, what did I... Okay, we got x old, x new. Oh, yeah, okay, that's x. We're talking x. Now we're switching to, we need to figure out the new velocity of y, which would be page 26, number 7. And that's from column number 5, row number 1, table number 1. Okay. So that is where you take the Vy, the new Vy. So let me get the table real quick. We're going to show you what we're talking about here. So that is the new Vy. To get this right here, basically you just take this and you add it to that. That's as simple as that, right? It looks strange right now because there's a 0 in there, okay? But that's as simple as it is right there. You just take change in Vy plus the previous Vy, and that will give you the new Vy, which in this case was 5.779 times 10 to the 4th meters per second. Okay, so the next thing we need to do, which you can follow along on page 26, number 8, calculate the new Vx. So this is a little different there. To get the new Vx, the velocity of x, you take this here, square root of v velocity of the alpha particle squared minus the velocity of y squared. Okay? Now we assume that the particle, alpha particle, remember this is alpha, it's kind of funny there, maintains speed throughout its trajectory. Okay, so put into calculator as follows. So square root, now parentheses, this parentheses is not going to be closed out until you get down here. Then you got a parentheses here, you take your velocity of alpha particle. Okay, so the question is, do you remember where we got that? Let's see, where did we get that? Do I have it here? Velocity of alpha particle. I think it was on page 1, was it, did I say? Or 25, I mean? Let's see. Velocity of alpha particle. Alpha particle along its path. Or was that, oh, here. Velocity of alpha particle. Huh, where do we get that? Well, anyway, this is what it is. I'm sorry if I forgot that. Or did I write it down here? The velocity of the alpha particle. Okay, VA, that's what that, remember that V and this little funky little sign? Well, that's alpha. Alpha, the symbol for alpha. You guys remember what language that is? Okay, let me know. You ever heard alpha and the omega, the beginning and the end? Well, this is the beginning particle. Okay, so this is how we plug it in. We got your the velocity of the alpha particle, 1.5 times 10 to the 7th, and squared. Make sure you get your parentheses here and here. Make sure you close off the power with parentheses. Make sure you remember to square it. If something goes wrong, go back and see if you squared it. Minus, parentheses, and then you got your velocity of y. In here, same thing. We've been doing this, right? Parentheses. Make sure you watch your parentheses. And then you come up with an answer like this: 149998888.68, right? Okay. So as number 2, page 25 says, we need to go to the precision of at least 4 significant figures. Therefore, the new Vx equals 1.500 times 10 to the 7th meters per second. Okay? So now you should have all the information you need. Now next, what else do we need here? Then calculate the change in Vy as done in step 3. Remember how that is? That's like this. Remember that big long one? And then repeat the steps 4 through 10 on page 26 until table number 1 is done. Then be sure to plot your locations on figure B graph or do a Google Doc. Remember B graph. That's the B graph I'm talking about right there. You can just plot it there. It seems easier than to do that, but it's up to you. And then number 12 on page 26, Find the final angle of 0 of the alpha particle. Use last 2 points, alpha particle's trajectory. Now I'm calling it 0, but it means something. I apologize, I've just now forgotten. But anyway, it equals this long little fun little thing on page 26, number 12. This fun little equation here. See if you can figure that out, and we'll talk more later.